right, wonderful and bright students that showed up today. We are doing trigonometric equations day 1. Okay. Over this section, we're going to talk about linear methods, the zero factor property, quadratic methods, trig identity substitutions, and if time allows, we'll look at an application where this would be applied. Okay. So up first, we have 2 sine theta plus 1 equals 0 over the interval 0 to 360 degrees. So you're trying to find an angle from 0 to 360 that would make this equation true, okay? Just like any other time you are solving an equation, your goal is to get your variable by itself. Does that make sense? Just like before. So if I have 2 sine theta plus 1, what would be the first thing I need to do to start getting sine theta by itself? I'm going to subtract 1 from both sides, correct? After I subtract 1 from both sides, what is the second thing I need to do to get sine theta by itself? I'm going to divide by 2. At this point, I'm now asking myself, at what point on my unit circle does sine theta equal negative 1/2? So remember, sine is positive in what quadrant? The first and the second. So it can't be in quadrant 1 or 2. So it has to be in quadrants 3 or 4. So in quadrant 3 and 4, when is sine theta negative 1/2? 210 degrees and 330. Does that make sense? So we're going to be in quadrants 3 and 4. We go to look at our quadrants 3 and 4. And if you're trying to figure out if you're sure, that means your reference angle is 30 degrees. So I have to be 30 degrees from 180 in quadrant 3 and 30 degrees from 360 in quadrant 4, which puts us at, like you said, 210 and 330 degrees. Okay, this is our basis of solving an equation. This would be on the non-calculator part of the test because, as you can see, did we have to use a calculator to solve this? Yes.
We have to prove that.
Also, is it always going to be like 30? Reference angle?
No, the reference angle can be 60, it could be 45, it could be.
But it's like both equal.
Yes, yes. Because you can use your reference angle is based off of your quadrant 1, right? So in quadrant 1, that's when the y value is 1/2 is at 30 degrees, right? And if I need negative, I'm now going to use that reference angle knowledge to find the negatives in quadrants 3 and 4. How do we feel about ground zero? We can build up. We're good. We have a sturdy foundation. No shakiness. Sure. I think we're good at ground zero. Yeah. All right. So our answer is 210 and 330. If it asks me for any other values outside of 0 to 360, remember those are my coterminal angles. And to find those values, I'll either add or subtract 360. Do you remember that? Because you go around and around a circle infinite amount of times. Okay. Up next, let's try it again. So now we have sine theta times tan theta equals sine theta. Okay. So using our logic, what would tan have to be here? 1. In order for this to be true, we're looking for what makes tan theta 1. Because this wouldn't be true otherwise, correct? Yeah. And what quadrants is tan positive? Well, technically it could be positive. Yes.
45.
At our 45. So anytime we're looking. So, and the goal here is, if you were to subtract, we're going to go the long way, but like your logic said, Johnny, keep it. We're going to go the roundabout way of mathematically how to prove this. So what I want you to do is combine all of your trig values to one side. So I'm going to subtract sine theta. Once they're now combined, we're going to factor out what they have in common. And what do they have in common? Sine theta. So we factor out our sine theta, right? Once we factor out sine theta, this is where we use our zero property. Okay, so your zero property is saying that you can set sine theta equal to 0 and tan theta minus 1 equal to 0. That's our zero factor property. Do y'all remember that from algebra? that if you have two factors equal to 0, you can separate them and solve them separately? Yes, perfect. So like you said earlier, Johnny, we know that for tangent, we're looking for when tan theta equals 1, but we also have to take into account when sine theta equals 0. So we got to take into that account. Does that make sense?
Yeah.
Okay. So now as we keep thinking, we're like, okay, well, if theta equals 0 degrees, or theta can equal 180, that's when sine is 0, right? Agree? That's when sine equals 0. Or, like America said, using our 45 degrees to get your positive 1 angle. Because we have to be in quadrant 1 or in quadrant 3. And our 45-degree angles in quadrant 1 is 45, and in quadrant 3 it would be 225. Still, did we use a calculator? No, we just used our big brains.
Not on the test, but like for this equation. See it. I don't think- We're allowed to calculate it.
Oh,
All right. Okay, so how do we feel? Level 1. We're at level 1 now. Okay,
So how is
so right here, so we factored out sine theta, right? And now with using our 0 factor property, that means we're going to take sine theta. I will let me write. That means that we're going to take sine theta and set it equal to 0, and we're going to take tan theta minus 1 and set it equal to 0. So in order to get tan theta by itself, what did we have to do? Add the 1. So we know that we're looking for when does tan theta equal 1, and when does sine theta equal 0. Okay. And it's at all these points. So sine theta means that we're looking for when does y on our unit circle equal 0, and that's at 0 and 180. And for tan theta, we're looking for when does y equals x on our unit circle, and that's at 45 and 225. So from sine theta, it gave you that answer. And from tan theta, it gave you that answer, but both would be applied. So all 4 would work. So there's 4 answers for this problem.
But
because if I plug in 0, is it not going to make everything equal to 0? It will, because 0 equals 0. Yeah. So if I plug in 0 degrees here, right? Sine of 0 degrees, tan of 0 degrees, sine of 0 degrees, it's going to come down to 0 equals 0. That's a true statement. If I plug in 180, 180 plugged into theta, no matter if 180 plugged into theta is going to give me a value, but as long as sine theta gives me 0, what's going to make this entire thing? 0, right? You knew that tan theta had to be 1 so that sine could equal sine. That was a great analysis from the beginning. But there was a little bit more that we had to dive in, which was acknowledging that sine theta itself could equal 0, and 0 equals 0s is a valid answer. Okay, so your solution set would be all 4. 0, 45, 180, 225. So I would be looking for all 4 answers. Got it? There are some free response questions on your next test. Mhm. All right, how do we feel about level 4? Level 1. Level 1. Yes, this is level 1.
We're gonna have cosecant and cosecant.
And in the next in 6.3. I think. All right. So here, like you did, Johnny, you did automatically where you got 1, but notice that you would have only gotten half of the answers, right? So you would have been partially wrong. So be careful when you are trying to find the quick shortcuts and not acknowledging the other trig functions. Yeah, exactly. Okay. So then you'll avoid missing those other solutions. All right. Okay. Level dose. Okay. So here it says tan squared x plus tan x minus 2 equals 0. Do y'all remember when we talked about last chapter about u substitution? Letting u equal our trig value? That's what we're going to do here. So we're going to let u equal our trig value. And what is our trig value right now? Tan x. So we're going to let u equal tan x. So everywhere it says tan x, we're going to replace it with a u. So I'm going to show you without it. I'm going to work it with the u because to me, it makes it better because you use what you already know. Okay. So we have u squared. Sorry. Ux squared. U squared plus u minus 2 equals 0. That's not a u. I'm trying to make my u's and I'm writing everything but a u. There we go. U squared plus u minus 2. Because I keep thinking x's, you know, on that. Can we not solve that? What? Yes, we can. What multiplies to give me -2, but adds to give me 1. Two and a -1. Yeah. So we have u minus 1 times u plus 2 equals 0. So what that means is that my factored form here is tan x minus 1 equals 0 is what I'm solving. And then I got to solve for when tan x minus plus 2 equals 0. So on the first one, we're looking for what? 1. We need to know when does tan x equal +1? And we just did that, right? So for what values of x does tan x equal +1? 45 degrees and 225 degrees. On the other one, we're asking, when does tan x equal -2? Do we remember our tables that we said what are the restrictions on the inverse of tan? So if you go to your chart that you made for 6.1, right? Yeah, yes, yeah, 6.1. Okay. What are the restrictions for the x values for the inverse of tan? So, and then what's the range for inverse of tangent?
Oh,
So like here,
0 to 5.
so you're looking at your domain. So your domain restrictions here is that it's from, your interval is from -π/2 to π/2. So we're looking for, is there a value for x between -π/2 and π/2 that would make this,
Oh, because
it's the inverse. Yeah. Yeah. So it's negative, so we have to be in quadrant 4. So in quadrant 4, is there an angle that's going to give me a tangent value of -2? Are you going to be honest here?
Are we looking at the
Okay, so we knew these parts, right? We got the easy part is x equal 1, right? I mean, it's your notes. If you're comfortable reversing, then your notes. So we know it's 45 and 225, correct? For sure. Now, what happens with the tan x equal -2? Is that possible? No, it's not possible. So our only solutions from 0 to 2π would be π/4, and
so it's no solution.
it would be it would just be these two only because they're the only ones that fit from 0 to 2 pi. Does that make sense?
Isn't 2 times pi like 6 something? Oh, wait, that's negative.
Mhm.
I'm like,
You're looking for the ratio to be a -2. Yeah. Okay. So I'm like, well, I looked on my unit circle. I don't see that on there. Guess what that means? That is all you have. You only can put what you have
so
on
you
your
let me
circle.
show them.
I just wanted you to think.
I was looking here for.
So proud of you.
Like, look for it.
Yeah, it wasn't.
You're lying. You're always okay.
All right, but does that make sense? When you looked at it first, you're like, I think it's possible. Good job, big brains. All right. Okay. All right. So up next, we are gonna just explain a little bit more why it's not on there. If you were to take the inverse of -2, right? It will be approximately -1.1, blah, 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 blah. That angle falls here in quadrant 4. Okay. If I'm going to add 2 pi to make it negative. So then this would be the value we could calculate using a calculator. But if you didn't have a calculator, then you wouldn't know.
So we would have to find the actual solution of the calculated part,
Mhm.
but not on the one.
Exactly. So if I gave this as a non-calculator, I mean, on the non-calculator part, these would be the only values I expect you to give me are the exact values, because you would be able to use your unit circle to find the inverse values. Does that make sense?
Yeah.
You would have to have the calculator to do the inverse values.
Okay.
Okay. But if this is on the calculator part, it's free game. You're going to set it up as a inverse and just use the calculator and let the calculator do the work. We would add 2 pi because it says in the range of 0 to 2 pi. So adding, yeah, if you did it in degrees, then you'd be adding 360. Okay, because tangent is going to be negative in 2 locations. Where are they negative at? In quadrant number 2 and in quadrant number 4. But our inverse calculator is only going to give us in quadrant 1 and quadrant 4. Remember that? Okay, so we have to be comfortable finding the other one. Okay, all right. Up next, here we go. Find all solutions of cotangent. It is in this section. I thought it was the next one. Cotangent x times cotangent x plus 3 equals 1. What do you think we should do? Never. You're going to distribute. Good job. See? And you wanted to give up and you knew what to do. Give up. No. We're going to distribute. No, it's not. And then when we distribute, it just becomes a what? A quadratic. Yeah. When we distribute, it just becomes a quadratic. And do we know how to solve quadratics? You guess so. Of course we know how to solve quadratics. The quadratic formula. You want me to sing it for you? Here we go. It does make me happy. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, okay? The quadratic formula is going to be applied. So first you're going to identify what's your a, your b, and your c. So from here, our leading coefficient is 1. So that's our a. Our middle term is 3, positive 3. And our constant is -1. That is our c. We're going to plug them into the wonderful quadratic formula. So we plug them into the quadratic formula and we're going to do the math. Okay. You have to use a quadratic formula when it's not factorable mentally, right? And there's nothing that's going to multiply to give me -1 and add to give me 3. So that tells me I have to use the quadratic formula. Okay. So we plug our values in and we do our little math. So we get -3 plus or minus 9 plus 4, which gives us 13 all over 2. Now, this would have to be on the calculator part of your test. Got it? I was like, this would have to be on the calculator part of your test. So what you're doing is you're going to find the inverse of this. We're going to use it in the calculator. In the calculator, I do not want you to put the decimal. I want you to actually put in this. So we're going to practice. I'm going to go taskbar. if you want to practice with me. If not, it's up to you. Okay. Remember, if I'm doing cotangent, I'm actually going to have to use what in the calculator? I'm going to have to do tangent, right? So I'm going to have to find the tan inverse. And the tan inverse means that I'm using the reciprocal of this. Does that make sense? So it's going to be the reciprocal, which means I'm just doing what with the fraction? Flipping it. So it becomes 2 over -3 plus or minus the square root of 13. Does that make sense?
Oh.
Remember, they're reciprocals, so we just gotta reciprocate. The only reason why you would do the 1 over is if you had the decimal, the singular whole value. But if you already have a fraction, you just need to flip it, okay? All right, the plus or minus means that I have to do it twice, right? Once as an addition and once as a subtraction. Agree? All right, so I'm gonna go here. I'm gonna go second tangent, and I have 2 divided by, parentheses to protect my denominator because it's more than one term, -3 plus the square root of 13. Close parentheses. So I input. When there's more than one term in your numerator and denominator, for my calculator, because I can't have separate numerator and denominators, I have to make sure I use parentheses. I'm going to press enter, and it's going to give me my first value. The reciprocal inverses. I mean, I'm sure they could have programmed it in our calculator. I'm going to arrow up and hit enter to retrieve it so that I can just change it from a plus to a minus. Who's going to retype all of that? Not me. You are? Okay, America. I'm not. And what do you notice on this one? What does it say? Error, error. Did you get an error? Or your negative?
Wait.
Oh, I tripped. I put a negative symbol. Your teacher did it. You know, it's fun. This is called Your Teacher is Human. And this is live example of when you press the wrong minus. Yeah, I did it on purpose to show you what happens. Okay, how do we feel about inputting in with reciprocal? It's all right. All right, now let's look at it if you chose to do it the other way. So let's say you chose to figure out what your value is using decimals first. So you're here at cotangent x equals all of that. Why would I want to do that instead of just putting in what I already have? I don't know, weirdos. Then you would have to do the cotangent inverse. Well, cotangent inverse, can we do that in the calculator? No. So that's where we have to do the tan inverse and do 1 over, right? Why would I want to do that when I could just reciprocate it from the quadratic equation formula, right? So that's why I would say do that. Now, why is this one 2? What did we do here? We had to add. We had to go around. So we had to add 2 pi. Because you had to make 360 to make it out of the negative, right? So right here on our minus, it gave us this result, right? So to make that into my criteria of being between 0 and 2 pi, I would have to add 2 pi to find its coterminal that resides there. Is it just, oh yeah, because we're in the negatives, right? Thank you, John. I see that. What are you talking about, Johnny? For coterminals, you just need to add the 1. Yeah. To get it out of the negative. There we go. It gave us a domain. Let me go back. Did it not tell us the cotangent? So like where we lie on our the box. Which is why we add the pi, not the 2 pi. Because we only could be in 1 and 2. Okay, if it asks us to find any other, we would just continue to add pi and go around and around. But if I'm at negative, whatever it was on the thing, I would be in quadrant 4 instead of in quadrant 2, which is why we have to add the pi to get us to 2. Because what all inverses are 1 and 2? Do you remember? Cosine, secant, and cotangent. Their inverses are all in 1 and 2 is what the answer is going to give you, right? That's where they have to be. They're only defined in 1 and 2. Sine, cosecant, and tangent are defined in 1 and 4. Yes? Okay. How are you feeling about solving so far? Is it as bad as you thought it was going to be?
Easy when you get like watch.
Oh,
Yeah.
so I can't be there with you.
When you get these, but that's how I'm gonna.
No, you're not. You're gonna practice and then get good. The thing is that there's so many possible equations, right? That they can give you. So I only can show you as many as I'm like, oh, this is what'll pop up. Oh, this is a good one. Let's try this guy. Okay. All right, here we go. Tan x plus the square root of 3 equals secant x. Huh? It makes no sense. Where would you start here?
And or make it into some.
Believe it or not, you would square each side. You know why I'm squaring each side? I'm getting rid of the square on the 3, right? The square root on the 3. You figure you knew that? Good job, Tom. So we're going to square each side. And after I square each side, this is what I'm left with. I turned it into a quadratic. Now, secant squared x, we're going to use our identities so that it's all in terms of tangent, right? Because in order to use the quadratic, I need this to be in terms of one trig function. Okay? So secant squared can become tangent squared by using the Pythagorean identity. Y'all remember our Pythagorean identities from chapter 5? I know it was not your favorite chapter, but in chapter 5, we talked about secant squared equals 1 plus tangent squared. It cancels out on the last term, but it's going to create the middle term when you have, when you fold, remember it's double distribution, aka FOIL. Yep. I used FOIL in one of my classes. They're like, we never learned that word. You're confusing us. I said, you're just double distributing.
Yeah, I never.
I think you're just double distributing.
The words, but I know what to do.
Yeah, it's just double. It's a little cute way of remembering to double distribute.
Does it really matter the word?
The order helps to make sure that you're multiplying everything to each other. That's it. All right, so then now we're going to clean it up. So notice here on both sides, I have a tan squared x. So what happens to tan squared x? It cancels out. So now I can eliminate tan squared x, and we're just left with 2 square root of 3 tan x. So now I'm down to one single trig, and I can simply get that by itself. I combine like terms and I eliminate. So what's the last thing I need to do to get tan x by itself? We're going to divide. We're going to divide by 2 square root of 3. And 2 square root of 3 comes down to negative 1 over the square root of 3, which gives us negative square root of 3 over 3. Because the 2's do what? Cancel out. So if this was on the calculator side, you just go straight to finding the tan inverse. Does that make sense? Okay, I'll just go, oh, perfect. Tan is not by itself, so now I can use the inverse feature. Yes? Or If it wasn't, then you have to use your brain and use your unit circle.
Wait, so either way, we still have to solve all this just to use 10 by itself. right?
Mhm. You have to get 10 by itself. Okay, now, if this is a calculator problem, I want to show you, I know you guys tend to work better with decimals, but with degrees. So I'm going to model this using. I'm going to go to mode. I'm going to switch to degrees. And then I'm going to. So I'm going to do tan inverse of negative square root of 3 divided by 3. Close parentheses, hit enter. And notice it tells me it's negative 30 degrees. Okay, why does it tell me it's negative 30 degrees? That's because the inverse of tan is only defined in quadrants 1 and 4. Does that make sense? So it's going to put me in negative 30 degrees, which is equivalent to what?
330.
330. And what is 330 in radians?
11
11 pi over 6. Does that, do we see that connection? Okay, tangent is also negative in quadrant number 2. So if I need to go to quadrant number 2 and I'm at 330, I have 330 minus 180 is going to put me where? Oh, what did I type? Oh, I keep pressing it on the computer and it puts in a negative symbol instead of a minus symbol. That puts me at 150. What is 150 in radians? 5 pi over 6. Okay.
Wait, so we can still have an answer from quadrant 2 even if.
Yes, the calculator isn't going to give you the answer though. It's only going to give you values in quadrant 1 and in quadrant 4.
Oh, so we still have to answer possible solutions.
You still have possible solutions in the other that fit that restriction. So the only thing it tells us came down to is our tangent has to be negative. There are 2 quadrants where tangent is negative.
Oh,
The
because-
calculator isn't going to tell you both answers. It's only going to give you quadrants 1 and 4.
Because it said the interval is 0 to.
Because the interval is from 0 to 2
unless
pi.
Unless there's a specific.
Exactly. Unless they give you a specific interval, then you have to analyze it as the whole entire circle.
Okay.
Okay. So if you struggle with kind of like working through it with the radians, does seeing it play out in degrees on the calculator help? Does that help or hurts? It helps. Okay. Somewhat. So you can be in degree mode and work the problem. Just remember, if it's asking for radian or start off with radian, this is how you know you're giving me radians is because what is my interval from? 0 to 2 pi. When it's talking about degrees, my interval is from 0 to 360. Okay. All right. But remember how I told you about those puzzle pieces that we learned in chapter 5? Those puzzle pieces are now in play. Like you have to know, okay, well, if I do this here, this will work. If I multiply this, I can get rid of this. It is not a straight path with it every single time you're going to multiply. You're going to have to think about, okay, what is the relationship between tangent and secant? Well, the only relationship I can think of between tangent and secant is Pythagorean identity. How can I make Pythagorean identity work? In order to have Pythagorean identity, it has to be squared. So I'm going to square both sides in order to make it squared so I can use substitution. Okay, so it does require you to do a little more. Okay. And you can double check yourself. So what does it come back to be when we talk about the quadrants?
It's not.
So we have what's called, do you remember what those are called? Starts with the E. It's a extraneous solution. Okay. So 5 pi over 6, it works in our problem, right? But it's an extraneous solution because when I plug it back into the original in the very beginning, what did it do? Did it make an equal statement? No, it did not. So it may ask you for your real versus your extraneous, and you need to be comfortable. That's why it's always good to check yourself. If you have these values, take them and plug them back into the very original problem. And if it works, then they both are real. If it doesn't work, then the other one is your extraneous.
So like, if it is training, would be-
If it asks for your real and what's your extraneous. So like, you know how sometimes on the homework, it's 2 parts. It'll ask you what's your real and it'll ask you what's your extraneous, or it'll only ask for the real answer. So it'll either ask for both or it'll only ask for your real solution. Okay. This tends to happen a lot with square roots. And radicals, we did this when we did squares, radicals, and rationals in college algebra, identifying extraneous and real solutions. So notice here, I plug it in and what works smoothly, right? So this is my extraneous and this is my real. 9 times out of 10, your real is going to be the one that satisfies the inverse rules in your equation. So like 11 pi over 6 satisfied our inverse rule, right? 5 pi over 6 logically was just another possible answer. But 9 times out of 10, the one that satisfies your inverse rules, or it's going to be your real. Okay. Again, it's important to plug in and check. If you don't like checking, I'm sorry, I'm saying, get over it. Just get over it. You also can check using the calculator, meaning that you can plug it in just like this in the calculator, plug that just like that in the calculator. But if you have your unit circle, that's where that skill comes into play. So our only real solution is 11 pi over 6. All I really have at the end is just kind of tips on solving trig equations. So tips, decide whether the equation is linear or quadratic form. So meaning, how should I approach it? Am I going to approach it using linear, which means just getting the trig by itself and going from there? Or am I going to have to do a manipulation to turn into a quadratic and solve using quadratics? If only one trig function is present, first solve the equation for that trig. Isolate the trig value, right? So you want to isolate the trig value. Other thing, if there's more than one trig function present, the goal is to get the equation equal to 0 and to see how you can condense it down to 1 using your trig identities, okay? Whether it's through factoring, whether it's through substitution, you want to condense it down to one of the trig identities because you can't take the inverse of tan and sine for that one problem. Does that make sense? If the equation is in quadratic form, but not factorable, you're going to use the what? Quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, okay, you're going to use that. And then you want to make sure that all intervals for your inverse and for the given problem are applied. Identities are your friends, okay? When you're trying to eliminate, see what identity you can use to substitute in for that value. And that is all I have. Once again, check for your what solutions? Extraneous. Always plug and check, okay? So if you put in the answer that says, oh, no, you're wrong, there's a chance that you're not wrong. You just also included your extraneous, okay? All right, perfect. Y'all are awesome.